Every person on Earth carries two stories within them, one written by their fathers and one written by their mothers. While Y chromosomes trace paternal lines, mitochondrial DNA tells a very different story, the story of our maternal ancestry. And at the heart of Europe's maternal history lies one woman. She lived thousands of years ago, and her descendants make up almost half of all modern Europeans today. Geneticists call her lineage Haplogroup H, but you could call her something simpler, the mitochondrial mother of Europe. This is her story, one that begins in the Ice Age, travels through the birth of agriculture, survives plague and empire, and still lives inside millions of people today. To understand Haplogroup H, we need to go back, way back, to a time when Europe was still frozen under walls of ice. Around 25,000 to 30,000 years ago, Europe was home to small groups of hunter-gatherers. They lived in caves, hunted reindeer and mammoth, and moved constantly to survive. Somewhere among them, a single woman gave rise to a new branch in human evolution, mitochondrial haplogroup H. Scientists believe she lived in Western Europe, possibly near what is now Spain or southern France, regions that remained habitable even during the Ice Age. When glaciers covered much of northern Europe, these areas became refuges for humans, places where our species could survive and adapt. As the climate warmed and ice sheets retreated, her descendants began to spread north and east, and with them, Haplogroup H began its long journey across the continent. Between 15,000 and 10,000 years ago, as the Ice Age ended, the world began to change. Forests grew where tundra once stretched, animals migrated north, and humans followed. The women carrying Haplogroup H were among them. Their mitochondrial line, passed exclusively from mothers to daughters, slowly repopulated the continent. By the time farming began to spread into Europe from the Near East, around 8,000 years ago, Haplogroup H was already widespread. It mixed with the DNA of early Neolithic farmers who brought agriculture from Anatolia and the Fertile Crescent. The result was a genetic fusion, a blend of ancient European hunter-gatherers and new agricultural settlers. And, at the core of the fusion was Haplogroup H. Today, about 40 to 50% of all European women belong to Haplogroup H, making it the single most common maternal lineage in Europe. But its influence doesn't stop there. You can also find it in parts of North Africa, the Middle East, and even Central Asia. A sign of ancient migrations, trade, and interconnection. Subgroups of H, known as H1, H3, H5, and H13, tell even deeper stories. H1 and H3 dominate in Western Europe and the Iberian Peninsula, a genetic echo of Ice Age survivors. H5 and H13 appear in the Balkans, the Caucasus, and the Near East, evidence of back migrations and trade across ancient crossroads. Each letter and number represents thousands of years of mothers passing life from one generation to the next, unbroken, unstoppable. So, why did Haplogroup H become so successful? Well, part of the answer lies in adaptability. Mitochondrial DNA actually controls the energy production inside cells. You could think of it as the power plants of life. Some scientists believe that certain H variants offered small advantages in cold climates by improving energy metabolism. These tiny differences may have helped Ice Age Europeans survive those longer winters, reproduce more successfully, and, expand faster when the climate warmed again. Over time, those small advantages really added up, until Haplogroup H became Europe's dominant maternal line. When agriculture arrived from the Near East, it didn't erase the older hunter-gatherer lineages, it actually merged with them. Ancient DNA from Neolithic sites in Spain, France, and Germany shows that Haplogroup H women married into early farming communities. They helped carry agriculture westward, raising families in stone villages, tending to crops, and, forming the first settled societies in Europe. By around 5000 BCE, Haplogroup H was no longer confined to the western refugees of the Ice Age. It was present from the Atlantic coast to the Black Sea, woven into the genetic fabric of the continent. Civilizations rose and fell, but Haplogroup H endured. It survived the migrations of Indo-European tribes, the collapse of Rome, and, honestly, the shifting frontiers of empires. Every time armies marched, trade expanded, or new settlers arrived, women of Haplogroup H carried life forward. In Roman Britain, Viking Scandinavia, and medieval Spain, their mitochondrial signature appears again and again, constant through chaos. It wasn't just survival, it was continuity. While empires burned, the motherline kept moving quietly through time. Modern genetic studies have revealed incredible insights into Haplogroup H. In 2008, scientists sequenced the DNA of a 7,000-year-old woman from northern Spain, known as La Braña woman. Her mitochondrial DNA, Haplogroup H. In 2014, mitochondrial DNA from Ötzi, the Iceman, the 5,300-year-old mummy found in the Alps, revealed he carried a rare variant of Haplogroup K, closely related to H, showing how these lineages coexisted during Europe's early history. From caves to cathedrals, ancient graves to modern genomes, Haplogroup H appears as a continuous thread connecting Europe's deep past to its living present. Mitochondrial DNA doesn't care about borders, ethnicity, or modern labels. It passes silently through generations, unchanged except for rare mutations. That means if you belong to Haplogroup H, your maternal line connects directly, person to person, through thousands of years of history. You could trace it back through medieval farmers, Iron Age villagers, Neolithic pioneers, and finally to that Ice Age mother who lived before writing, before metal, before history itself. She didn't know it, but her daughters would become the mothers of nearly half a continent. There's something profoundly humbling about mitochondrial DNA. It reminds us that survival wasn't always about conquest or power. Often, it was about resilience. While empires were built by kings, humanity endured through mothers, through quiet strength, care, and continuity. Haplogroup H stands as a monument to that truth, the persistence of life through nurture, not domination. And even beyond Europe, the story of H connects to others, to M and L in Africa, to B and F in Asia, to A and C in the Americas. Together, these maternal lines form a living web of ancestry that stretches around the entire planet. Today, science can map Haplogroup H down to remarkable detail, revealing how its branches moved, adapted, and survived. But beyond the data, it tells a timeless story. Every mother who carried it gave the next generation a spark of energy in her cells, the same mitochondria that fuel your heartbeat right now. That spark never died. It crossed ice, ocean, and empire to reach you. So when you think about Haplogroup H, don't imagine an ancient fossil in a lab. Imagine a woman sitting beside a fire 25,000 years ago, cradling her child. She had no idea her lineage would still exist tens of thousands of years later. But through her, through every daughter since, it does. The mitochondrial mother of Europe is not a myth. She's real. And if you carry her DNA, she's still alive inside you.